Hello, welcome back to my recorded classes. This video we are discussing the topic 1.4 proof methods. This is the topic from module 1 logic and proofs. So, let's start the content. Before starting, all of you please subscribe my channel for getting more recorded classes. Okay, so let's start directly to the section 1.4 proof methods. Here mainly we are discussing two methods. One is the direct proof method and second one by contraposition. Okay, proof by contraposition. So first we will discuss the direct proof method, then method by contraposition method or indirect method. We will call it as indirected method. So let's go to the first method, direct method. Before starting to the methods, just to see what are the terms we are using here. Okay, some small definition for your understanding. First, theorem. What is the meaning of theorem? Theorem means a statement that can be shown to be true. It is a true statement that we can prove it is true. Okay, so that type of statement we are calling a theorem. Hope you understood. So theorem means a statement that can be shown to be true. That statement always it will be true. We can prove that one, correct? So like that statement we are calling theorem. Now proof of a theorem. Proof means the explanation, correct? If you are getting a statement, a theorem, a mathematical statement, correct? We need to prove that one. So how we are proof? What is the meaning proof? It is just the explanation of why the statement is true, correct? Theorem means it is always true. So we need to prove that one. How we are proving? Just explaining, okay, how they are proving or why the statement is true. So that is calling proof. And the third one we are calling axioms and postulates. Okay, axioms and postulate. Axiom means basic assumptions about a mathematical situation, like hypothesis of the theorem to be proved, correct? Basic assumptions, some basic assumptions about a mathematical situation. So before starting a main theorem, maybe we have some basic assumptions about the theorem. That are all we are calling axioms or theorem or hypothesis of the theorem, we can say in simple way. Now third one we are calling it as lemma. Okay, lemma means it is a simple theorem, small theorem used in the proof of other theorem. That simple theorem we are used to prove the other bigger theorems. Okay, so like that small theorems we are calling, we can call it as lemma. Now the next one is corollary. What is the meaning of corollary? Corollary means a theorem that follows from another theorem, correct? It is just a theorem only, corollary, but it follows from another theorem. Okay, so what we are doing, we have one theorem already proved, one theorem will be there. From that theorem we are going to another theorem, it is calling corollary, or a theorem that follows from another theorem. It is coming from another theorem, like that theorems we are calling corollary. Now conjecture, another word we are using is conjecture. Conjecture means a statement whose truth value is unknown. Okay, so that means we have a statement, but we are not proved that is true or false, like that. We are truth value, we don't know that one, correct? One, it is just a statement. But when the conjecture is proved, okay, if it is proved, it become a theorem. It is just like a theorem only. Theorem means we have a proof, correct? It is already proved, or we can prove that one. But conjecture, what is the problem? It is just a statement, but truth value unknown. Nobody proved that one. But if it is proved that one, it become a theorem. It is just like a theorem only. So these are the basic definitions we are using here. What is the meaning of theorem? Proof, axioms, lemma, corollary, and conjecture. Okay, now let's start the method of proving theorem. So if you are getting a theorem means, I told here, it's just a statement that can be shown to be true, correct? That theorem we can prove it is true, correct? By some explanation we need to give. So how we are proving a theorem? Okay, method of proving theorem. There are two methods I told. Direct method is there and indirect method is there, or method by contraposition method is there. So first we will go to the direct method or direct proof, correct? So we will go to the direct proof here, direct proof method here. So what we are doing in the direct proof method, how can we prove a theorem directly? Okay, the proof of the theorem directly, that is what we are discussing here. So what are the steps? So for example, we have a conditional statement P implies Q. For example, we have a conditional statement P implies Q. That means, what is the meaning of this one? If P is true, correct? If P is true, then Q also true, correct? Then Q. That means we are studied before sections. Remember all of you, what we are writing is simply this conditional statement. If P, then Q, correct? If P, then Q. That is the conditional statement, or P one-sided arrow, Q we are getting, correct? So from this, how we are proving if we are getting a theorem like this? What we are doing is, in step 1, assume that P is true. Okay, what we are doing, assume that P is true. Okay, that means we need to assume this is true, P is true. Then what we need to show, in step 2, we need to show that Q is also Q is true. Because of P is true, Q is also true. That means this part is true, correct? So it concludes that, okay, first we assumed P is true, we got Q is also true, that it concludes that P implies Q. That means if P is true, then Q is also true. This is what we are calling direct method. Okay, directly we are proving. That means we have a condition P, Q, then first assume P is true, then prove that Q also true. Like that proof method we are calling direct proof method. Okay, that means assume like this, P implies Q. Okay, so first what we are doing, assume that P is true, correct? Assume, this is, we are assuming this is true. Okay, then what we need to do, then we need to show, we need to prove, we need to show that Q is also true, correct? Then we can conclude from this, if it is correct, then we can conclude P implies Q, that theorem is true. Okay, so this is what we are doing here. So let me do one question here. You can see, prove prove directly that if x greater than 2 and y greater than 3, then x plus y greater than 5. Okay, prove directly. So for example, see this statement. First see what is the theorem here, or what is the statement here. Prove directly. Okay, direct method we need to use. Prove directly that if, okay, if, you know this if statement, if and then, correct? That means one-sided arrow, correct? That is conditional statement. So if x greater than 2 and y greater than 3, this is the P statement. Okay, we have P here. If x greater than 2 and y greater than 3, then what is we need to prove? X plus 5 is greater than 5. This is the Q statement. Okay, so once you get a question, what we are doing, just identify what is the P statement. P statement is x greater than 2 and y greater than 3. This is the P statement. Now second one, what is the Q statement? We need to prove what is Q actually. Then x plus y also greater than, x plus y greater than 5. If x greater than 2, y greater than 3 means x plus 5 is greater than 5. That means if you are taking a number more than 2 and another number more than 3, when we are adding these two number, answer should be more than 5. That is what we need to prove in this statement, correct? So here the question is P implies Q. We need to prove this conditional statement P implies Q. If P is true, Q also true, we need to prove that one. Okay, so we will go to the proof that one. Okay, I will do here the proof statement. So what we need to do, we start from the P statement. Okay, we just start from the P statement. P statement true means Q also true. That is, we need to do that one. So assume that this P statement is true. Okay, so first what we need to do, assume, okay, assume that P is true. Okay, assume that P is true. That means I am starting from the P statement. P is true means, what is the P actually here? X greater than 2 and y greater than 3, correct? This is the P statement, x greater than 2 and y greater than 3. Here we are written x greater than 2 and y greater than 3. This is a P statement. Now from here, see, from here we need to prove x plus y greater than 5 here, correct? Now in this statement, see, I am just doing here x greater than 2 and y greater than 3, and, correct? You know the and symbol, this symbol, both are true, correct? X and y both are correct. Just add add the P statements, x greater than 2 and y greater than 3, add both the statement, correct? Adding by addition, okay, add the statement, okay, adding. So how to get when we are adding addition rule? X, this is the left side is here x, here left side is y, so x plus y greater than, see, here also greater, here also greater, so greater than, right side is 2 plus 3, correct? X plus y greater than 2 plus 3, left side we are added, right side we are added. So what is the answer? That is x plus y greater than 2 plus 3 means 5, correct? X plus y greater than 5. X plus y greater than 5 we got, correct? What is actually x plus y greater than 5? It is the Q statement. That means Q is true. That is the meaning, correct? X plus y greater than 5 means that implies Q is also true, correct? Q is also true. So we started from P, correct? We started from P, we got implies Q. That means when P is true, Q is also true, okay? That means our statement is true. This is the proof of our statement. That means x plus y, x greater than 2 and y greater than 3, x plus y also greater than 5. So this is what the proof of this statement. So I hope you understood this question. What we do, we just start from the P statement. P is true, assume that P is true. After that, what we need to reach? We need to reach Q. Q is also true, correct? We need to prove that Q is also true, that one. So if you are getting like this, that means P implies Q is also true, that one. So this is the proof of this question. Hope you understood this question. Okay, let me do one more question here so that you will understood more. Question number 2. Okay, question number 2, prove directly. Okay, direct proof we need to use. Prove directly that if n is even, then n square is even, correct? If means I told a conditional statement. N is an even integer. N is an even integer. That is the P statement. And n square is also even number. That is Q statement, correct? So we have P statement. What is the P statement here? P statement is n is an even integer, correct? Or n is an even number, even integer, okay? And Q statement is n square is even. N square is an even integer, correct? So this is the Q statement. That means our question is, P statement is like P implies Q, we need to do. That means when P is true, Q is also true. We need to prove that one, correct? When P is true, Q is also should be true, correct? That means if n is an even integer, that means if you are taking an even number, square also will be an even number. For example, see, before starting this question, you can see, for example, if you are taking an even number 2, correct? Even number, that is n, okay? Now just check the square of that one, n square, 2. What is the square? 4. So n is even number, correct? 2 is an even number. 4 is n square is also what happened? Is also an even number. Same like 4. Okay, you know what are the even number? 2, 4, 6, 8, like that, correct? So 4 is an even number. So what about 4 square? So 4 square 16. 16 also an even number. Like that, if you are taking any even number, square also will be an even number. That is what our question we need to prove that one, correct? Now you studied before courses, I hope. Even number, how to write even number generally, how to write odd numbers generally, correct? For example, even numbers means 2, 4, 6, 8, correct? Like this going. And negative even numbers also we can take. Here I am taking positive even number 2, 4, 6, 8, like that. Now even number means any number, it is of the form n equal to 2 times k. Any even number we can write like this, n equal to Even number equal to 2 times k. For example, 2. If you are taking 2, how to write that 2? 2 multiply 1, correct? 2 multiply 1 is 2. 4 means how to write that one? 2 multiply 2. 2 multiply 2 is 4. 6, how we are writing? 2 multiply 3, correct? 8, how can we write? 2 multiply 4. Like that, any even number when we are taking, we can take 2 common, all the cases. See, 2 multiply 2 multiply 2 multiply 2 multiply, correct? 2 multiply k, where k, for k, some k belongs to z. Z means integer, k means an integer number. For example, 2 multiply 1, 1 is an even number, integer, 2 is an integer, 3 is an integer, 4 is an integer. So instead of k, we can take some integers. For example, 2 multiply 1, 2, even number, 2 multiply 2, even number, 2 multiply 3, even number, correct? Like that. So any even number, okay, we can write like this: n equal to 2 times k, 2 multiple of an integer, 2 multiply k form. Now if it is an odd number, you know what are the odd number? Generally we are using 1, 3, 5, correct? 1, 3, 5, 7, like that it is going. Now odd number means always we can write the odd number like n equal to 2k. 2k means even, plus 1. Okay, 2k plus 1 form. Generally I am writing n equal to 2k plus 1 or 2k minus 1 also. Okay, 2k plus 1 we can use where k belongs to z. Okay, integer number, k is an integer number. So odd number means we can write like this: for some k belongs to z, n equal to 2k plus 1 form. For example, you can see the number 3 or number 1 first. Number 1 equals, how to write number 1? 2 multiply 0 plus 1, correct? 2 multiply 0 means 0 plus 1. So 1 we are getting. 3 is an odd number. How can we write like this? 2k plus 1. 2 multiply 1 plus 1, because 2 multiply 1 is 2 plus 1 means 3. Now when we are taking 5 number, how to write 5? 5 means 3 multiply, 2 multiply 3, 2 multiply 2 plus 1, correct? 2 multiply 2 is 4, 4 plus 1, that is 5, correct? Same you can write whole number. For example, 7, how to write 7? 2 multiply 3, that is 6, plus 1, correct? That is 7. So odd integer means always we are writing 2k plus 1, 2 multiply k plus 1. Only 2k means even number, 2k plus 1 means odd number. So I hope you understood this one, how to write odd number and even number generally. Now we will go to the question here. Come to the second question. Prove directly that if n is an even integer, then n square is even number, correct? N square is an even integer. So what we are doing, assume that, first we need to assume p is true, correct? Assume that p is true. That means p means, what is the meaning p actually? P means n is an even integer, correct? N is an even integer, correct? N is an even integer. Now n is an even integer means, how to write n actually? N equal to, just now we wrote even. Even means how to write? N equal to 2k. For some k belongs to z, correct? Or k belongs to z. For some k belongs to z. Z means integer number. K number is an integer number, 1, 2, 3, 4, 5, 6, like that. Okay, so n equal to 2k we can write if n is an even number. Now what we need to prove that, students? N square is an even. We need to prove n square is an even number. Q statement we need to prove. So what you need to know, just start n square. What is n square? You will get even or odd. Okay, so n square equal to, n means what? 2k, correct? N value is 2k. N square equal to, n square means, how to write that one? N means 2k. So 2k whole power 2, correct? Just applied the n value. So 2k whole power 2. 2k whole power 2 means 2 square means 4. K power 2 means k square, correct? 4k power 2 we are getting. Now 4k power 2 means it is an even number, it is obvious, 4 multiply, correct? But we can write like this: 4 means 2 multiply 2, correct? That is 4. K square same. So 2 multiply 2k square, same, it is 4k square. Why we are written 2 multiply 2k square? Because even number n square is an even number, we need to prove, correct? N square should be an even number. Even number means always it is the form 2 multiply an integer, correct? So that's why we are written like this one. Now from here, this 2k square, okay, this 2k square, just we are taking like any value like r or s, any variable you give this for. For example, I am taking r. So how to write this one? It is equal to 2 times r, correct? Where r means r equal to 2k square, okay? Hope you understood this one. This 2k square I am taken as r, 2 outside is there, so 2 times r, okay? So it is coming like this, 2r. 2r means that number should be what type of number? 2 times k, like that, correct? So it should be an even number, correct? That means n square, what we got? N square is an even number. N square is an even number means what is the meaning actually? Q is also true, correct? N square is an even number means what is the meaning? Q is true, correct? Q is also true. So where we started actually? We started with P is true, okay? Then P statement, we calculated n square. N square number also we are getting an even number. So Q is also true. That means if P is true, then Q is also true. We proved that theorem. That means P implies Q is true. P is true means Q is also true, that one. Hope you understood this question. We will do more question in the exercise. Now we will go to the second method, proof by contraposition or indirect method, okay? Proof by contraposition or indirect method. So here what we are doing, if you want to prove a statement P implies Q, if P is true then Q is true, that is a direct way. Now indirect way or proof by contraposition, we need to prove P implies Q means we just take the contrapositive of this one, contrapositive proof. You remember in the first section we are studied the contrapositive, P implies Q, correct? What is the contrapositive of this one? Negation of Q implies negation of P, correct? Negation of Q implies negation of P. So what we are doing is, instead of proving P implies Q, this is the direct proof. What we are proving actually, just to prove negation of Q implies negation of P, okay? That means what we do, just assume, okay? Just assume negation of Q is true, okay? Assume negation of Q is true. What we need to prove? We need to prove, okay, we need to show that, or we need to prove that negation P is also true. This is the method we are calling indirect method. Indirect method or proof by contraposition, okay? Or by contraposition, proof by contraposition method. So I hope you understood. If you are doing directly, for example, if you are doing P implies Q directly, this is calling direct method, correct? Directly P implies Q, that what we are doing. If P is true, then we prove Q is also true, correct? Assume assume here P is true, and we need to prove Q is also true. That is direct method, okay? That we did the question now. Now instead of proving P implies Q, we are proving negation of Q implies negation of P. That is the indirect method or proof by contraposition method, okay? Hope you understood. So memorize this one. Step 1, assume that negation of Q is true, okay? Instead of proving P implies Q, negation of Q implies negation of P we are proving. So assume that negation of Q is true. We need to show that negation P is also true. That conclude that negation Q implies negation P. Negation Q implies negation P means what is the equivalent statement? P implies Q, okay? Logically equivalent to P implies Q, that one. So this is the indirect proof or proof by contraposition. Okay, let me do one question here. You can see, prove by indirect method, okay? Prove by indirect method or contraposition, proof by contraposition. What we need to prove here? If one conditional statement is there, if and then means arrow. What is the first statement? You can see P statement, x plus y greater than 5. X plus y greater than 5. Then what we need to prove? We need to prove the Q statement also true. If this is true, then this is also true. If x plus y greater than 5, then x greater than 2 or y greater than 3. We need to prove this one, okay, this statement. If P is true, then Q is also true. So first identify what is P here actually. X plus y greater than 5, correct. What is Q here? Q means x greater than 2 or y greater than 3, correct. X greater than 2 or y greater than 3 here. So this is the question here. So we need to prove P implies Q, correct. Indirectly, okay, we need to prove P directly. P implies Q indirectly. That means we need to prove like this: negation of Q implies negation of P, correct. So let me start this question. I will do here in separate. So first I am writing the P statement before starting the question again. P means, what is the statement here? Already we written here P statement: x plus y greater than 5. X plus y greater than 5. What is Q here? Q means x greater than, here we written x greater than 2 or y greater than 3. X greater than 2 or y greater than 3 here, correct. Now before doing this question, better to write what is the negation, okay. Negation of this statement, just to write. For example, negation of P. What is the negation of the P statement? Opposite of that one. That means x plus y, instead of greater than, we are writing less than or equal to 5, okay. Just opposite the symbol, in between symbol, just opposite. X plus y less than or equal to, greater than negation is less than or equal to 5. Now here I want to write the Q negation, negation of Q, okay. So negation of Q means negation of, first I am writing what is the Q statement, correct. What is the Q statement? X greater than 2 or, you know, or symbol like this, or, and sorry, y greater than 3, correct. Negation of x greater than 2, negation of x greater than 2 or y greater than 3, correct, or y greater than 3. Now we need to apply this negation. For this one, we studied one rule, that is De Morgan's law. De Morgan's law. Use this one, De Morgan's law, for applying there. What is the De Morgan's law actually? Negation of P or Q, okay. Negation of P or Q means, how we are writing negation of P or Q by De Morgan's law? Just apply negation here first. Negation P, then negation of this or statement. Or negation means and, okay, and negation of the second one, that is negation of Q. This is the De Morgan's law, okay. Just apply this De Morgan's law here. Negation of P or become and, negation of Q, okay. So I am applying here. You can see what we are writing: negation of x greater than 2, correct. What is negation of x greater than 2? X less than or equal to 2, correct. Greater than become less than or equal to, greater than become less than or equal to. Negation I am applying here first, then negation of this, or this negation of y greater than 3, correct. So x less than or equal to 2 we are getting. Hope you understood. Now or become and, correct, and statement. Y greater than 3 becomes y less than or equal to 3. Greater than become less than or equal to 3. This is the negation of that statement, negation of Q. Hope you understood how we are getting negation of Q here. So before starting the question, better to do this one. What is negation of P and what is negation of Q? Now I am starting the proof of the statement. Where we need to start? We need to start from negation of Q. Assume that, correct, assume negation of Q is true, correct. This is the contrapositive, proof by contrapositive. We discussed it here. First we need to start negation of Q is true. Then we need to prove negation of P also true. Then that means P implies Q, correct. So we start with the negation of Q is true, okay. That means I am starting negation of Q is true. What is the meaning negation of Q? Here we are written x less than or equal to 2 and y less than or equal to 3, correct? X less than or equal to 2 and y less than or equal to 3. Just use the addition, correct? Addition rule use. X less than or equal to 2, y less than or equal to 2 means we can add both sides. See, x and y, add the left side, here x, here y. So x plus y less than or equal to, add the right side, 2 plus 3, correct? 2 plus 3 by addition. Okay, use the addition rule. So addition. So that means x plus y less than or equal to 2 plus 3 means 5, correct? X plus y less than or equal to 5 we are getting. So if q is true, this is also true, we got now. See, x plus y less than or equal to 5 means, what is that one? Negation p, correct? That means negation p is true, correct? That means negation p is also true. That means what we concluded? We concluded that negation q implies negation p. That means negation q true, negation p also true. That means that is logically equivalent to p implies q by contraposition method. This is the proof. If you got negation q implies negation p, that is same as p implies q. That is the proof of that statement. Hope you understood that one, how we are proving this contraposition method. Okay, now let me go to the another one, question number 4. Prove by indirect method, correct? Prove by indirect method that if 3n plus 2 is odd, that is the p statement, then n is odd, that is the q statement, where n is an integer. Okay, so proof by indirect method or contraposition, proof by contraposition. Okay, so let me start. What is the p we are writing first? What is the q we are writing? P means 3n plus 2 is odd, correct? Q means n is odd. Q statement means n is odd. Now, as I told you last question, first write the negated statement also before starting the question. What is the negation of p? Negation of p means 3n plus 2 is odd. What is the negation? 3n plus 2 is even, correct? Opposite, correct? Not odd means even. Not odd means even. So 3n plus 2 is odd. Now what is negation of q? Negation q. N is an odd number. So n is not an odd number means n is even number, correct? So n is even. That is the negation of the q statement. So before starting the question, we are writing the negated statement here. Now we are starting the question. Where we need to start by indirect method? Negation. We need to assume negation of q is true, correct? We need to assume negation of q is true. That means negation q, that means negation of q is true means, what is negation of q? N is an even number, correct? N is an even number. Now we studied n is an even number means, how to write n actually? N equals 2k, correct? N equal to 2 multiply k, where k, for some k belongs to which type of number? K, integer number. K belongs to z number, correct? For some k belongs to z. N equal to 2k. Now what we need to prove? This is, we assumed negation of q is true, that is n is an even number, n equal to 2k. Now what we need to prove actually? Negation p is true, correct? Negation p. That means what we need to do? 3n plus 2 should be an even number. So just to check what is the value of 3n plus 2. 3n plus 2 equals, correct? N already there. N means 2k. Just apply that n value here. Okay, hope you understood. See, n value already here. N equal to 2k. Just apply n value here. So 3 times, instead of n, write 2k plus 2, correct? 3 multiply 2k plus 2. Just multiply. 3 multiply 2 means 6. 6k plus 2, correct? 6k plus 2. Now we need to check this is even or odd. 6k plus 2 is an even number or odd number. We need to check that one. If it is even, negation p is also true. So what we do is, from here these two we can take it 2 common, correct? 2 is common here in both numbers. So 2 I am taken outside. 2 multiply. What are the balance? 6k becomes 3k, correct? Because 6 is the number, 2 we are taken outside. So 6 by 2, it becomes 3 now. 3k plus. Now 2 we are taken 2 outside means 2 by 2, 1 balance, correct? So 2 multiply 3k plus 1. 2 times 3k plus 1. Hope you understood. Now this 3k plus 1, you can take it like r. Okay, you can take it r. So how to write this step actually? We can write, okay, 3n plus 2 equals, what we got? 2 times r, correct? Hope you understood. Here see, we started with 3n plus 2. 3n plus 2 we got 2 multiply 3k plus 1. That means 2 multiply this bracketed term we are taken r. R means 2k plus 1. Okay, where r equal to 2k plus 1, correct? So what happened actually? 3n plus 2 equal to 2r. What about this number 2r? It is an even number, correct? 2 multiply an integer means it is an even number, correct? That means what we got actually? 3n plus 2 is even, correct? 3n plus 2 is an even number. 3n plus 2 is an even number means what is the meaning actually? This one, 3n plus 2 is an even means negation p, correct? So I can write implies negation p. So where we started? We started with negation q. We got negation p also true. This means, okay, this is meaning negation p is true, correct? That means negation q implies negation p. We got negation q implies negation p. That means negation q implies negation p means what is the logically equivalent to p implies q. That is the proof of that statement. Hope you understood this question. Can practice so that it will be easy. Okay, now let's start the questions from the exercise regarding these two. How to prove by method by contraposition, and second first one direct method. So we will go the question one by one. The first question, prove the statement using contraposition, okay, or indirect method. Prove this question by statement using contrapositive proof. Okay, so just now we did same model. Suppose that x belongs to z. If x power 3 minus 1 is an even number, then x is an odd number. So x cube minus 1 is even p. X is odd, we are taking as q. So we need to prove in this question p implies q, correct? So instead of proving p implies q, what we are proving in contrapositive proof, negation of q implies negation of p, correct? So this is what we need to do here by contrapositive method. So first we are writing what is p. Okay, p means x power 3 minus 1 is even. Now write what is q. X is odd, correct? Now as I told you before starting the question, just write what is negation of p and negation of q, correct? What is negation of p? X power 3 minus 1 is even. So what is the negation of that one? X power 3 minus 1 is not even. Not even means x power 3 minus 1 is odd, correct? Now what is the negation of q here? X is odd. So x is not odd. That means x is an even number. So this is the negation of q here. So before starting the question, just write negation p and negation q. Now start with the negation q, correct? So I will be here. Start with the negation q. So what we need to do? Assume negation q is true, correct? Assume that negation of q is true. We need to assume. So start with the negation q. means what is the negation q? Actually, we written here x is an even number. X is even, correct? That means x is even means even number, correct? Even number, how we are writing? We discussed it. That means x equal to 2 multiply k for some k belongs to z, correct? K is an integer number. X equal to 2k where k is an integer number. Hope you understood. Now that means, now what we need to prove actually? Negation of p is also true, correct? Negation p. What is negation p? We need to prove here. X power 3 minus 1 should be an odd number. So just to check what is x power 3 minus 1. Is it odd or not? If it is odd, it is also true. Negation p also true. So just to start from here, x power 3 minus 1, correct? So x power 3 minus 1 equal, what is x actually? X equal to 2k. Just before step we wrote, correct? X equal to 2k. So just apply x number here. Instead of x, we are writing 2k power 3 minus 1, correct? Now just going to simplify that one, equals 2 power 3 means 8. K power 3 means k cube minus 1, correct? Now we need to check this number is odd number or even number, okay? If we are getting x power 3 minus 1 is odd number, negation p also true, okay? So just to check this is odd or even. So here we are using a little logic here. See, 8k power 3, I can show here 8k power 3 minus 1, correct? Here 2 is common. 2 number you can take it outside, correct? We can common, but here it is not common. So instead of minus 1, what we do is, instead of 1 means 1, we can write, how to write this minus 1 number? Minus 2 plus 1, because minus 2 plus 1 is minus 1. Why we are writing like that? Then we can take 2 common. For example, if I am writing if I am writing like 8k power 3 minus this minus 1, if I am writing minus 2 plus 1, minus 2 plus 1, because minus 2 plus 1 means minus 1 only. If I write like this, from here and here I can take 2 common, correct? 2 if you are taking outside, how much you get? From 8, if you are taking 2 outside, 4 will be balanced. So 4 k power 3 from minus 2, correct? So 2, if you are taking 2 outside, 1 will be balanced. See, like this. Then plus 1 we will get separately. That's why we are written minus 2 plus 1. 2 we need to take common. Now see, 2 multiply one number means it will be an even number, correct? 2 multiply 4k power 3 minus 1, even number. Plus 1 means what happened? It will be an odd number totally. Understood? This is what the idea here we are doing. So here we are doing same idea, 8k power 3 minus 1. I am writing 8k power 3. Instead of minus 1, I am writing minus 2 plus 1. This is logic you are using. You can think, and you can think the logic behind that one. From this 2 I am taking outside. So 2 multiply, what will be balance? 4 k power 3 minus 1, because 2 multiply 4 8, 2 multiply 1 2, okay, plus 1 after that, plus 1. Now you can think about this one, okay, the first one, 2 multiply 4k power 3 minus 1, correct? If I am taking this 4k minus 1 as r, for example r, okay, so how to write that step? Equals 2 times r plus 1, correct? Because 4k power 3 minus 1 is r, where r equal to 4 k power 3 minus 1, okay? So we got 2r plus 1. 2r plus means 1 means that number will be what type of number? It is an odd number, correct? 2r even, plus 1 means odd, so odd number. So what is odd number? We started from where? X power 3 minus 1. X power 3 minus 1 is odd, correct? What is the meaning x power 3 minus 1 odd? We started here, see, x power 3 minus 1 odd means negation p, correct? So I can write negation p, okay? Where we started? Negation q true, we are started, we got negation p also true, correct? This means x power 3 minus 1 odd means what is the meaning? negation P is true, correct? So negation Q implies negation of P, correct? That means, what is the meaning? P implies Q. That is the proof of that statement by using contrapositive method. Hope you understood this question. Okay, you can try, you can practice that. Okay, now let me go to the next question. Prove the statement using contraposition. Okay, prove the statement using contrapositive or indirect method. Suppose that x belongs to z. If x plus y is an even number, then x plus y have the same parity. X and y have the same parity. That is the Q. Okay, same parity means, what is the meaning? Actually, if x is even, y also even. That is the meaning, same parity. X is even, y also even. If x is odd, y also odd, like that. Same parity it will be. Okay, same number, same type of number. X even, y also even, like. Okay, so let's start this question. First I am writing what is P. P means x plus y is even, correct? Now Q, what is Q? X and y have the same parity, correct? X and y have the same parity, correct? Hope you understood. Now, before starting the question, we need to write what is negation P and what is negation Q. What is negation P here? X plus y is even. So, what is the negation of that one? X plus y is not even. That means x plus y is odd, correct? Now, negation Q. What is the negation Q? Q negation. X and y have not the same parity. No, not the same parity, correct? So what we can write? Not same parity, not same parity. That means if x is even, what happened? X is even and y is odd, correct? Same parity, not same parity. Not same parity means one number is even, another number is odd, correct? Opposite one. Okay, same parity means x even, y also should be even. That is the same parity. But negation means opposite. X even, then y will be odd, like that. Okay. So before start the question, I wrote what is the negation P and what is the negation Q. Now what we need to prove? If first assume negation Q is true, first assume negation Q is true, then we need to prove negation P is also true, correct? Negation Q true means, what is the meaning? X is even and y is odd. From that we need to prove x plus y is odd number, correct? So start from here, negation Q is true. We need to reach here, negation P is also true, correct? Okay, so let me start here. Okay, first we need to assume negation Q is true, correct? So start from negation Q. What is the meaning negation Q? We are written here. X is even and y is odd, correct? X is even and y is odd, correct? That means x equal, x is even. Even means how to write? 2 times k, correct? X equal to 2 times k and, and means the symbol, correct? And symbol. Y is odd. So y, how can we write? Y equals 2k plus 1. Here k already we used. We can use another letter 2m plus 1. Okay. Y is an odd number means y we can write 2m plus 1. Plus 1 is the odd number, correct? So y equal to 2m plus 1. Hope you understood. Where k number and m number belongs to z, correct? Are integer numbers. K and m are integer numbers. Okay. Now that means, okay, where we need to reach, we need to assume x plus y, what type of number? That is what the we need to reach that statement. X plus y, what type of number, correct? Just to see, x equal to 2k and y equal to 2m plus 1. We can use the addition rule, correct? We can add. So just add, addition. So how to write that one? Left side here x plus y equals 2k. What is x plus y? 2k plus 2m plus 1, correct? 2m plus 1. X plus y equal to 2k plus 2m plus 1. That means what we can write? X plus y equals, x plus y equals 2k plus 2m, correct? We can take 2 outside, or it is your logic, it is correct. You can think like logically also. 2 multiply, what is balance? K plus m, then plus 1 separate, correct? Plus 1. What about 2 multiply k plus m, this number, odd number or even number? Should be even number because 2 multiply, correct? But we have plus 1 balance is there. So what happened? That one, x plus y should be, x plus y is what type of number? Even plus 1, that means odd number. X plus y is odd number, correct? X plus y is odd number means, what is the meaning? I told x plus y is odd. You can see here, x plus y is odd. That is negation p, correct? That means negation p is also true, correct? Negation p is true. That means what we got? Negation q true means negation p is also true, correct? That is the proof. That is logically same as p implies q. So this is the proof of that question. Hope you understood. So this question we started with the negation q, x is even and y is odd. We got x plus y is odd. That means negation q implies negation p. That is the proof of our statement. Okay. Now question number 1c part. Question number 1c part. You can see, if n is odd number p, then 8 divides n square minus 1. That is the q. What is the proof statement using direct proof here? Direct proof. Direct proof means p implies q, correct? If p is true, q is also true. Only we need to check. No need to contraposition or negation, nothing. Direct proof, okay? So what is the question? If n is odd, then 8 divides n square minus 1. What is this symbol? This symbol, maybe you know that one, a divide symbol, correct? For example, I am asking I can ask, for example, 2 divides 4 or not. We are calling it is 2 divides, not divide, divides 4 or not. That is the question. How to check that one? Just to take the second number divided by the first number, 2. Okay, what is 4 divided by 2? 2. It is an integer, correct? Integer number. If you are getting an integer number, you can use this symbol. 2 divide 4. 2 divides. Okay, not divide, divides. So divides. Okay, 4 divides. Second number divided by first number should be an integer number. That is the meaning. Integer means, you know, 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, like this number, correct? Okay. Now, for example, I am asking one question. 4 divides 16 or not. So we can check what we do. Second number 16 divided by first number 4. That is 4, correct? It is an integer number. So that is correct. It is divide, correct? Now, same way, for example, if I am asking one question like 5 divides 29. Is it correct or not? We can check that one, correct? Just to check what is 29 divided by 5. You will get 5.8, correct? 5.8 is not an integer. Not an integer number, correct? So, is it correct? No, it is not correct. So, 5 is not divide. Just to cross that symbol, 29. Okay, 5 not divide 29. So like that, if one number divides another number means second number divided by first number. Okay, second number divided by first number. So keep in our mind this symbol, that meaning divides. Okay, this symbol division, divide, another one divides. Okay, that is the difference. Okay, now here what is the question actually? If n is odd number, 8 divides n square minus 1, correct? That means what we need to check actually, 8 divides n square minus 1, correct? Means what is the meaning, what we need to check actually, n square minus 1 divided by 8 for second number divided by first number. What is the second number? N square minus 1. What is the first number? 8. When you are dividing these two, you should get what? Should be an integer number, correct? Then we can say n square divides n 8. N square minus 1 divides 8. So this is what we need to check. Okay, this is keep in your mind. N square minus 1 divided by 8 should be an integer number. Okay, let me come to this question. First write what is the P statement here. P means n is odd. What is the Q statement? 8 divides n square minus 1, correct? 8 divides n square minus 1. When you are doing this one, keep in your mind what is the meaning. As I told you, what is the meaning actually? N square minus 1 divided by 8 should be an integer number. That is the meaning Q. Okay, now we will start the question now. Where we need to start? Assume that P is true, correct? Assume P is true. That means P, what is the P actually? N is odd, correct? P is given here. N is odd. N is odd means how to write n? N equals, we studied odd number means 2k plus 1, correct? Where k belongs to Z, integer number, correct? 2k plus 1. Now what we need to check actually, n square minus 1 divided by 8 is an integer or not? That is the question. N square minus 1 divided by 8. So just start with n square minus 1. Okay, because we are checking 8 divides n square minus 1, correct? Is correct or not? So start with n square minus 1. What is n square minus 1? What is the value of n? 2k plus 1. So 2k plus 1 power 2 minus 1. Instead of n, just write 2k plus 1, correct? We have here that one, n equal to 2k plus 1. Just apply here instead of n, 2k plus 1 whole power 2 minus 1. Expand this one, equal to, you know what is a plus b whole square? You studied a plus b whole square. What is a plus b whole square? A square plus 2ab plus b square, correct? Use this rule here. We can write 2k power 2, 4k square. 2 square means 4, k square, same, plus 2a multiply b, 2 multiply 2k multiply 1, that is 4k, plus b square. B square means 1 square, that is 1. Then last we have 1 minus 1, right? That minus 1. Got it? Okay, now equal to 4k power 2 plus 4k, here minus 1 and plus 1 we can cancel, correct? It will be 0. So 4k power 2 plus k. That means, okay, n square minus 1 equals, we got 4k square plus 4k. Take 4 common. So 4 multiply k square, sorry, 4k you can take common. So we can go here, 4k multiply k plus 1, correct? The last, see here, 4k square plus 4k, both term 4k is common, correct? So 4k take it outside, so we will get here k, here 1, correct? 4k square, we took 4k outside, so k balance, and from 4k we take 4k outside, so 1 balance, correct? So that's what we written here, 4k multiply k plus 1. Okay, now k means what type of number? K is an integer number. We are written here, k belongs to Z. K is an integer number, correct? Now if k is an integer number, k or k plus 1 must be even number, correct? K or k plus 1. For example, k equal to 2. So k plus 1 should be what? 3. So one number should be even number, should be correct, other number should be odd number, because k and k plus 1, correct. K adding 1 means it will go to the another type of number. One is even means another will be odd. So what happened here? Here k or k plus 1, one of this number must be what type of number? Must be even number, correct. That means what happened? This n square minus 1 equals, see, n square minus 1 equals this k multiply k plus 1. What happened? K or k plus 1 must be even means k multiply k plus 1 will be an even number, correct. Must be even means, see, k multiply k plus 1 should be an even number, correct. So what we can write totally must be an even number means 4 times an even number, correct. 4 times an even number means this should be what type of number? Even number. If you want, you can write more steps like k multiply k plus 1 equal to 2 times m, then you can substitute there, okay, so that you will get. So this is logic is very clear. 4 multiply k plus 1 should be an even number means 4 multiply k multiply k plus 1 also an even number, correct. That means what we got actually even number, it is 2m, we are taken as 2m. So how to write that one? Equal to 4 times even number means 2m, correct. 4 multiply 2m. Hope you understood. This is even. Even means we can write 2m where m belongs to integer. So I am just applying here 4 times 2m, correct. 4 multiply 2m. 4 multiply 2m means how much we got? 8m. So n square minus 1 equal to 8m, correct. Just divide both sides by which number? 8. So like this, n square minus 1 equal to 8m, divide by 8, divide by 8. So 8 will cancel. So n square minus 1 divided by 8 equals m. Why we divided by 8? Because where we need to reach? We need to reach here. N square minus 1 divided by 8 should be an integer number, correct. So that's why n square minus 1 divided by 8 equal to m. M, what about m number? Integer number. That means n square minus 1 divided by 8 is an integer, equal to integer. So if n square minus 1 divided by 8 is an integer means what is the meaning? 8 divides n square minus 1. Hope you understood, correct. That means what is the meaning of that one? P true means q is also true, correct. So that means what is the meaning? P implies q. Hope you understood this question, how we are doing. You can practice one more time. Started with p, n is odd, n equal to 2k plus 1. Then we calculated what is n square minus 1. We are taken 4k outside. Then k into k plus 1 is an even number. So k into k plus 1 we can write 2m, because even. Even means 2 multiply integer, 2m. Apply that 2m here, 4 multiply 2m, that means 8m, divide by 8. So 8 divided by n square minus 1. So p implies q. Okay, let me go to the next question. We have more questions here. Question number 3a. Prove the statement using direct proof. Again, we need to prove the statement by direct proof. If n is odd, then n square is also odd. So if n is odd, p, then n square is odd, q, correct. So p we are writing n is odd. Q means n square is odd. So if a n number is odd number, n square also odd number. That is the question here. That means, for example, n we are taken number 3. What will be n square? 9. 9 also odd number, correct. If n is odd number, n square also odd number. Okay, 5. For example, 5. What is 5 square? 25. 25 also odd number, like this. If 3 is odd, 9 also odd, n square also odd. 5 is odd number, n square, 5 square, 25 also odd number, correct. This is what our statement. We need to prove this one. Start with P, direct proof. Okay, so we need to start with P. P means, what is P? N is odd number, correct? Now, if n is odd, how to write n? N equal to 2k plus 1, correct? Where k belongs to Z. Now, what we need to check actually? We need to check n square is odd or not. Because P is true, we assumed. Okay, P is true. We assumed P is true. Okay, then we started. Now we need to check Q is also true. We need to show n square is odd. So start with the n square now. N square equal, n means 2k plus 1. So 2k plus 1 square. Use a plus b whole square. 2k square means 4k square. Okay. Then plus 2ab 4k plus 1. Correct. Now first two term we can take 2 common. 2 multiply. What will be balance? 2k square plus 2k, correct? Plus 1. Yes or no? Yes. You can take 4k also common. It is only for your understanding. So this number should be what type of number? Even number. Plus 1 means what type of number? Odd number, correct? Even number plus 1. Even number plus 1 means it should be odd number. Why it is even? 2 multiply, that is why even. Plus 1, it is odd number. So n square is odd. N square odd means what we are calling that one? Q statement also true, correct? That means Q is also true. That means what we can say? P implies Q is true. That means if P is true, Q is also true here. Hope you understood this question. It is easy. Now we will go to the question number 3b part. Question number 3b part. Prove the statement using direct proof. Okay, statement using direct proof. So what is that one? If m and n are even integers, P, then m plus n is also even integer, Q statement. Okay, so we will start. So P, m and n are even integers. M and n are even. Q, what is Q? M plus n is even, correct? M plus n is even. Okay, now we will start. Assume that, what we need to assume? Assume P is true. That is the direct proof, correct? So P means, what is P actually? M and n are even. Got it? M and n are even. So what is the meaning? M and n are even. How to write a m number and how to write a n number? That means m equal to, how to write even number means 2k, correct? And n equal to, how to write that one? N also even number. So we can write it 2 times r. Any 2 letters we can use. K and r I am using here. Where k and r belongs to z, integer number, correct? Now what we need to prove here? We need to prove m plus n is even. So just to calculate what is m plus n equal, just add these two. M plus n equal, what is m? 2k. What is n? 2r, correct? 2m plus 2k plus 2r. We can take 2 common. So 2 times k plus r. Is it even or odd? Even number, because 2 times, correct? It's an even number. So what happened? M plus n is an even number. That is what the Q statement. That means Q is true. That means if P is true, Q is also true. So what we can conclude here? P implies Q. That means if P true, Q also true. Hope you understood this question also. Let me go to the next one, question number 3C now. Now we did more questions, so you got idea, I hope. If m and n are odd integers, then m multiply n is odd number, correct? M and n odd numbers, then m multiply n also odd number. M dot means m multiply n is odd number. So this is P, this is q, correct? So I can write what is p. M and n are odd. What is q? M multiply n is odd. So first we need to assume p is true. Assume that p is true, correct? That means, what is the meaning p is true? M and n are odd numbers, odd integers, correct? That means m how can we write and n how can we write? Odd numbers. So m means, how to write that one? Odd number means 2k plus 1, and n how to write that one? Odd number. Odd number means another variable I can use 2r plus 1, like this, where k number and r number are integer numbers, correct? Odd number means always plus 1. Now we need to prove mn is odd, correct? M multiply n is odd. So just calculate what is m multiply n. M multiply n equals, what is m actually? 2k plus 1 multiply what is n? 2r plus 1, correct? You know how to expand this bracket, correct? Expand the bracket. So you will get, just expand 2k multiply 2r, 4kr, 2 multiply 2 4kr, plus 2k multiply 1, that is 2k, plus 1 multiply 2r, 2r, plus 1 multiply 1, that is 1, correct? Now first 3 term we can take it 2 outside, 2 multiply, what is the balance? 4kr, 2 taken outside mean 2kr, plus 2k, 2 outside means k, 2r, 2 outside means r, plus 1, correct? Plus 1. Now we can assume logically, okay, 2 times this number means it should be what type of number? Even. 2 times means it is even number. Plus 1, correct? Plus 1 separately here, you can see plus 1. Plus 1 means should be odd number, correct? Even number plus 1, that means it should be odd number. That means m multiply n will be odd number. That is the q statement, correct? That means q is true. If p is true means q is true. That means we can conclude p implies q is true, correct? If p is true, q is also true. So I hope you understood this question also. Now let me go to the last question here. Question number 3d part. Prove the statement using direct proof. If n is an odd number p, then n square minus 5n plus 7 is odd number, q statement, correct? So what is p here? P means n is odd number. What is q here? N square minus 5n plus 7 is an odd number, correct? So we will start the proof of this question. You can clear. First assume that p is true, correct? Assume that p is true. That means p means, what is p actually? N is an odd number, odd integer, correct? N is an odd integer. N is an odd integer. P is true. N is an odd integer means, how to write n? N equals 2k plus 1, correct? 2k means even, plus 1 means odd. So 2k plus 1, where k belongs to, some k belongs to z, integer number. K is an integer number. Now where we need to go actually? We need to go, q is also true. We need to prove that one. That means n square minus 5n plus 7 is should be an odd number. Like that we need to get. So just start n square minus 5n plus 7 equals, okay, just apply the n number already we know, n means 2k plus 1, just replace here n numbers, wherever n coming, just write 2k plus 1, correct? So we can write equals n square, n means 2k plus 1 square, n square, minus 5 times n means 2k plus 1, put it in a bracket, plus 7. Okay. Now use the expansion a plus b whole square here, 2k plus 1 whole square. So a square, 2k square means 4k square plus 2 times ab, 2ab, 2 multiply 2k plus 1, 4k plus b square, 1 square is 1, correct. Now after that this minus 5 distribute to the bracket, minus 5 multiply 2k, minus 5 multiply 1, minus 5 multiply 2k means minus 10k, minus 5 multiply 1 means minus 5, then last plus 7 same. Hope you understood how we are expanded. Now simplify, okay, what are the k terms there? Equal only 4k power 2, so 4k power 2. Now here 4k minus 10k, that is minus 6k. Now numbers 1 minus 5 plus 7, 1 minus 5 plus 7, 1 minus 5 means minus 4, minus 4 plus 7 means plus 3, correct. 4k square minus 6k plus 3, where k is an integer. Now we need to get this number should be an odd number. This number should be an odd number, 4k square minus 6k plus 3. So as I told you before one question, logically think 4k square minus 6k plus 3. This number should be an odd number. So you can think, see from here and here already 2 is common. 2 common, correct? But here is not common. You understood? So here this 3, how to write this 3? 3 just write 2 plus 1. See like this 4k power 2 minus 6k. Plus 3 means plus 2 plus 1, correct? 2 plus 1 means 3 only. Why we are written like this? Then this first 3 terms we can take 2 outside, correct? Then plus 1. So how to write? For example, 2 multiply. First 3 terms we are taken 2 outside. 4k square becomes 2k square because 2 we are taken outside. Minus 6k means minus 3k because 2 taken outside. Plus 2 becomes plus 1, 2 taken outside, correct. 4k square divided by 2, 2 taken outside means 2k square. 6k divided by 2 means 3k, correct. 2 divided by 2 means 1, like this. Taken 2 outside, plus 1, same, correct. Now what we can conclude very easily, we can conclude if you got this logic. 2 times this term means it will be an even number, correct. 2 times, 2 multiply, plus 1. Correct, even plus 1. Even plus 1 means what type of number that one? Should be an odd number. This is the idea we are doing. Hope you understood, correct? So same I am continuing here also one more time. So 4k square minus 6k plus 3 become plus 2 plus 1, correct? Now first 3 terms we are taken 2 outside. So 2 multiply, what is balance? 2k square minus 3k plus 1, then lastly plus 1, correct, like this. 2 plus 1. I told you the logic why we are written like that already. That means what we got actually, we can go equals, that means we got n square minus 5n plus 7 equals 2 times we got 2k power 2 minus 3k plus 1 plus 1, correct, like this. Last we got this step, correct. 2k square minus 3k plus 1 plus 1. That means this number is an even number because 2 multiply, correct. 2 is coming here, 2 multiply means even number, plus 1. Even number plus 1 means what type of number that one? Odd number, correct. That means what we got, n square minus 5n plus 7 is an odd number, odd integer, correct. That is what the Q statement. See, n square minus 5n plus 7 is an odd. So we go to Q. Q is true, correct. So we started from P. P is true. We got Q is true. That means what we can get it, P implies Q is true. That is what the proof of that statement. Hope you understood this question also. So we did direct method and indirect method, many questions. You can practice these questions so that you will get a good idea from this section. So I hope you understood all the ideas from this question, this section. So thank you for watching this video. Please subscribe my channel for getting more recorded classes. Thank you very much.